Good day, I am John Michael A. Gonzaga, and the topic that I will discuss is about the ellipse. So, ellipse. The ellipse is the set of all points for which the sum of the distance from two fixed points, the foci, is constant. So, for the example is d1 plus d2 equals to constant. The next one is the square root of a minus 1 times negative c squared plus 0 minus 0 squared plus the square root of a minus c squared plus 0 minus 0 squared equals to constant. When you solve this, it will become the square root of a plus c squared plus square root of a minus 2c squared. It is equals to a plus c plus a minus c equals to 2a. X plus c squared plus y squared equals to 4a squared minus 4a, the square root of x minus c squared plus y squared plus x minus c squared plus y squared. So, x squared plus 2xc plus c squared plus y squared is equals to 4a squared minus 4a, the square root of x minus c squared plus y squared plus x squared minus 2xc plus c squared plus y squared. Then 4xc minus 4a squared is equals to negative 4a, the square root of x minus c squared plus y squared. Xc minus a squared is equals to negative a, the square root of x minus c squared plus y squared. Xc minus a squared equals to negative a, the square root of x minus c squared plus y squared squared. X squared and c squared minus 2x c a squared plus a to the fourth power is equals to a squared 1 times x squared minus 2xc plus c squared plus y squared. X squared and c squared minus 2xc a squared plus 4a to the fourth power equals to a squared x squared minus 2xc a squared plus a squared c squared plus a squared and y squared. So x squared times c squared minus a squared minus a squared and y squared is equals to a squared times c squared minus 2a squared. X squared times a squared minus c squared plus a squared y squared is equals to a squared times a squared minus c squared. d1 plus d2 is equals to a, the square root of 1 times minus c minus 0 squared plus 0 minus b squared plus the square root of 1 times c minus 0 squared plus 1 times 0 minus b squared is equals to 2a. The square root of b squared plus c squared plus the square root of b squared plus c squared is equals to 2a. 2 the square root of b squared plus c squared is equals to 2a. So, minus natin, cancel out natin yung 2 which will be have this the square root of b squared plus c squared is equals to a. Then it will become b squared is equals to a squared minus c squared. X squared times a squared minus c squared plus a squared y squared is equals to a squared times a squared minus c squared. X squared b squared plus a squared y squared and is equals to a squared b squared. X squared over a squared plus y squared over b squared is equals to 1. Parts and properties of an ellipse. The two fixed points f1 and f2 are called the foci, plural for of focus. The point midway, f1 and f2, is the center of the ellipse. The axis of symmetry passing through the foci is called the principal axis of the ellipse. The line segment through the foci and joining 2 points of the ellipse is called the major axis. The major axis lies on the principal axis. The line segment through the center and perpendicular to the major axis is the minor axis. The endpoints of the minor axis are the points of the ellipse. The graph of an ellipse is symmetrical with respect both its major and minor axis. The intersection of the ellipse with the major axis determines the points V1 and V2, which are called the vertices. The endpoints B1 and B2 of the minor axis are called the co-vertices of an ellipse. The line segments through the foci perpendicular to the major axis and joining 2 points of the ellipse are called latera recta, plural of latus rectum. The fixed lines D1 and D2 referred to the definition of an ellipse and parallel to the latera recta are called the directrices, plural for directrix. The length of the major axis is always greater than the length of the minor axis. Length and distance involved in an ellipse. A equals to distance from the center to an end of the major axis, length of the semi-major axis. B equals to distance from center to an end of the minor axis, length of semi-minor axis. C equals AE equals the square root of A squared minus B squared is equals to the distance from the center to focus. 2A is equals to the length major axis, constant sum in the definition of ellipse. 2B is equals to the length of minor axis. Minor axis is less than the major axis. 2C is equals to distance between foci. 2B squared over A is equals to the length of each latus rectum. B squared over A is equals to the distance from focus to an end of the latus rectum. A over E equals to pi squared over C, distance from center, directrix. E equals to the square root of A squared minus B squared over A is equals to the eccentricity of the ellipse where E is less than 1. A greater than B and A greater than C. Major axis, x-axis, y-axis. Foci, F1 times C and 0. F2 times negative C and 0. F1 times 0 and C. F2 times 0 and negative C. vertice v1 times a and 0, v2 times negative a and 0, v1 times 0 and a, v2 is 0 and negative a. Minors, v are 0 and b, v2 are 0 and negative b, v1 is the b and 0, v2 is the negative b and 0. Directrix, x equals to a squared over c and equals to a over a. X is equals to negative a squared over c equals to a negative a n over e. Y is equals to a squared over c and it is equals to a over e. Y is equals to negative a squared over c and it is equals to negative a over e. Endpoints, E1 is the c and b squared over a, E2 is the c b squared over a negative, E3 is negative c and b squared over a, E4 is negative c and negative b squared over a, E1 is b squared over a and c, E2 is negative b squared over a and c, E3 is b squared over a and negative c, E4 is the negative b squared over a and negative c. S.F is x squared over a squared plus y squared over b squared equals to 1, which is a is greater than b, and y squared over a squared plus x squared over b squared is equals to 1, which is a is greater than b. So, example number 1, graph the ellipse with general equation of 4x squared plus 9y squared minus 36 is equals to 0. So, first, write the 4x squared plus 9y squared minus 36 equals to 0, then 4x squared plus 9y squared, we will divide it by 36 to cancel out the 36, which we will have the x squared over 9 plus y squared over 4 equals to 1. Then it will be x squared over 3 squared plus y squared over 2 squared equals to 1, which will be x squared over a squared plus y squared over b squared equals to 1. Therefore, a equals to 3 and b equals to 2, then c equals to the square root of a squared minus b squared, and c is equals to the square root of 3 squared minus 2 squared, which will be c squared equals to the square root of 9 minus 4 is equals to square root of 5, which will be the b squared over a equals to 2 squared over 3 equals to 4 over 3. Axis of symmetry equals to x-axis. C is 0 and 0. F is the square root of 5 and 0, and F2 is negative. It's the square root of 5 over 6. The square root of negative 5 and 0. The V1 is 3 and 0, and the V2 is negative 3 and 0. B1 is 0 and 2, and the B2 is 0 and negative 2. The endpoints for F1 is the square root of 5 and 0, and E1 is the square root of 5 and 4 over 3, and the F2 is the square root of 5 and negative 4 over 3. The endpoint for F2 is the negative square root of 5 and 0, and the E3 is the square root of 5 and 4 over 3, and the E4 is the negative square root of 5 and negative 4 over 3. And this is the graph of our example number 1. The graph the ellipse with general equation of 4x squared plus 9y squared minus 36 equals to 0. You have the B1 is 0 and 2. The C is 0 and 0. F1 is square root of 5 and 0. E1 is the square root of 5 and 4 over 3. The V1 is 3 and 0. The E2 is the square root of 5 and negative 4 over 3. And the B2 is the 0 and negative 2. The E4 is the square root of 5 and negative 4 over 3. The V2 is negative 3 and 0. The F2 is the square root of 5 and 0. And the E3 is the negative square root of 5 and 4 over 3. Ellipse determined by condition. And this will be our example. Find the equation of the ellipse with centers 0 and 0, equations of directions y equals to plus and negative 8, and the distance between foci is 6. So our given is C and 0 and 0. Directrix is y equals to positive and negative 8. Axis of symmetry is y-axis. Distance between foci equals to 2c equals to 6. So, c is equals to 6 over 2 equals to 3. Our F1 is 0 and 3, and our F2 is 0 and negative 3. Equation of direction, y equals to positive and negative a squared over c is equals to positive and negative 8. A squared is equals to 8c, and equals to 8 times 3 is equals to 24. And our A will be A equals to the square root of 24, which will be our V1 is 0 and square root of 24, and our V2 is 0 and negative square root of 24. So now it is C equals to square root of A squared and B squared. The square root of A squared minus B squared. So C2 equals to A squared minus B squared. Transpose B squared equals to A squared minus C squared. So our B equals to the square root of 24. The square root of 1 times the square root of 24 squared minus 3 squared, which will be the B equals to the square root of 24 minus 9, and B equals to the square root of 15, which will be our B1 is square root of 15 and 0, and our B2 is the square root of 15 and 0. Positive negative B squared over A equals to positive negative square root of 15 squared over the square root of 24 equals to positive negative 15 over the square root of 24. Positive negative a squared over c is equals to positive negative the square root of 24 squared over 3 equals to positive negative 24 over 3 equals to positive and negative 8. So our E is equals to C over A equals to 3 over negative 20 over the square root of 24 is equals to 0.612. So next is the y squared over a squared plus x squared over b squared is equals to 1, which will be y squared over square root of 24 squared plus x squared over the square root of 15 equals square root of 15 squared equals to 1. Then we will cancel out the square root and the squared, which we will have the y squared over 24 plus x squared over 15 equals to 1. Then we will have the 15y squared plus 24x squared is equals to 24 times 15. Then we will have the 24x squared over 3 plus 15y squared over 3 minus 360 over 3 is equals to 0 over 3. Then we will have the x squared, and we will have the final answer that x squared 8x squared plus 5y squared minus 120 equals to 0. This will be the graph of our example on ellipse determined by condition, which have our y equals to 8 and our v1 is 0 and the square root of 24. Our e2 is negative 15 and square root of 24, and our f1 is 0 and 3. Our e1 is 15 and square root of 24 and 3. Our c is 0 and 0. Our b1 is square root of 15 and 0. Our e3 is 15 and over the square root of 24 and minus 3. Our f2 is 0 and negative 3. Our b2 is the square root of 15 and 0. Our e4 is negative 15 over square root of 24 minus 3. b2 is 0 and negative the square root of 24. And that will be our final graphing po. Thank you for the listening to my discussion. I am John Michael A. Gonzaga. Thank you for listening on my discussion on Module 6, the ellipse.